Hello friends, I welcome you in lecture number 12 on complex numbers. In this lecture we are going to discuss this question which was asked in GTU Winter 2020 exam. So here we are asked to find the fifth roots of unity. Unity means we have to consider 1 as a complex number. So before going for finding roots of complex number 1, we just recall the formula for finding roots of a complex number. So suppose we have some non-zero complex number, say z, and if absolute value of z is small r and argument of z is theta, then nth root of z, this we can write in this way also, is given by this formula r raised to 1 by n, where r is absolute value of z, times cos theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n. And for these values of k, we will obtain n different roots of this complex number z. So for k equal to 0, 1, 2 and n minus 1, we will obtain n roots of complex number z. So with this in mind, we try to find out fifth roots of unity. So for that we first denote complex number 1 by z. We consider z equal to 1. Then we know that modulus of z is nothing but square root of real part square plus imaginary part square. We can write 1 as 1 plus 0i. So square of real part plus square of imaginary part, that is nothing but 1. And to find out argument of 1, we find the location of 1 in xy plane. So we know that 1 is located on x-axis in xy plane or in complex plane. And if we consider the vector representing 1, then that vector lies along positive x-axis. So angle made by this vector with positive x-axis is 0. So argument of z is nothing but theta equal to 0. So r is 1 and theta is 0, and we are interested in finding fifth root of unity. So we consider n equal to 5. So we first write down that formula, that z raised to 1 by n is r raised to 1 by n cosine of theta plus 2k pi divided by n plus I sin theta plus 2k pi divided by n. K runs from 0, 1, 2 up to n minus 1. So here we substitute r equal to 1, theta equal to 0 and n equal to 5. So therefore z raised to 1 by 5 equal to 1 raised to r is 1, n equal to 5. Theta is 0, so we have 0 plus 2k pi, that is 2k pi divided by 5 plus I sin, angle is same in cosine and sine. So we have 2k pi divided by 5 and n is 1, n is 5. So if we put n equal to 5, we have n minus 1 equal to 4. So we have to go up to 4 starting from 0, 0, 1, 2, 3 and 4. So for these different values of k, we will have 5 roots of unity. So we now find out all the roots corresponding to these values of k. So root corresponding to k equal to 0, that root is denoted by z suffix 0. And here 1 is considered as a real number. So we know that 1 raised to 1 by 5 is 1 if we consider 1 as a real number. And here we put k equal to 0. So for k equal to 0, we have, this is 1, so 1 times cos 0 plus I sin 0. Cos 0 is 1, sin 0 is 0, so this is nothing but 1. So root corresponding to k equal to 0 is 1. Now we find the root corresponding to k equal to 1. So if we consider k equal to 1, an angle will be here. If we take k equal to 1, angle will be 2 pi by 5, and this is always 1 for every root. So we have cos 2 pi divided by 5 plus I sin 2 pi divided by 5, and 2 pi by 5 is not standard angle, so we keep it as it is. Now we substitute k equal to 2, and we write root corresponding to k equal to 2, that we denote by z suffix 2. So here z suffix 2 will be equal to, here we have to put k equal to 2, so we have 2 into 2, 4 pi by 5. So root is cosine of 4 pi by 5 plus I sin 4 pi divided by 5. Now we calculate root corresponding to k equal to 3. So we substitute k equal to 3 and we obtain z3. So if we put k equal to 3, here angle will be 2 into 3, that is 6 pi divided by 5. So we have cos 6 pi divided by 5 plus I sin 6 pi divided by 5, and we can rewrite this angle. We can rewrite 6 pi as 10 pi minus 4 pi divided by 5 plus I sin 10 pi minus 4 pi divided by 5. So because this angle 6 pi by 5 is greater than pi, we try to write it in terms of angle which is less than pi. So for that we have rewritten 6 pi as 10 pi minus 4 pi. Now this I can rewrite as 10 pi divided by 5, that is 2 pi minus 4 pi by 5 plus I sin 2 pi minus 4 pi by 5. Now 2 pi minus 4 pi by 5 means up to this, if we complete one circle we have 2 pi, and we are subtracting 4 pi by 5. So we are in fourth quadrant, and in fourth quadrant only cosine is positive. So this is cosine 4 pi by 5, because cos is positive and sine is negative. So sine of this will be equal to minus sine 4 pi by 5. So this is fourth complex root corresponding to k equal to 3. So here I have to write z3. So this is z3. Here angle is now 4 pi by 5, which is less than pi. Now we find out the last complex root corresponding to k equal to 4. So for k equal to 4, we substitute k equal to 4 in that formula. So if we take k equal to 4, here we have 2 into 4, that is 8 pi by 5 plus I sin 8 pi by 5, that will be fifth complex root, which is denoted by z4. So this is cosine of 8 pi by 5 plus I sin 8 pi by 5. So here also angle becomes greater than pi, so we try to convert it in the angle which is less than pi. So we can replace 8 pi by 10 pi minus 2 pi divided by 5. Same thing here, 10 pi minus 2 pi divided by 5, and this can be rewritten as 10 pi divided by 5, that is 2 pi minus 2 pi by 5 plus I sin 2 pi minus 2 pi by 5. So 2 pi minus 2 pi by 5. So again we are in fourth quadrant. In fourth quadrant cosine is positive and sine is negative, so this is going to be minus I sin 2 pi by 5, and this is fifth complex root, z4 equal to cosine of 2 pi by 5 minus I sin 2 pi by 5. Okay, so in this way we can obtain fifth roots of unity. And one more thing I would like to write here as a note. Sometimes these roots can be written in exponential form also. For that we recall this formula, Euler's formula. We know that e raised to I theta is cos theta plus I sin theta, and if we replace theta by minus theta, we have e raised to minus I theta is cos theta minus I sin theta. So if we don't want to write cos theta plus I sin theta, we can write it as e raised to I theta, and cos theta minus I sin theta can be written as e raised to minus I theta. So here if we wish, we can represent this as e raised to minus I into 2 pi by 5, or simply e raised to minus 2 pi I divided by 5 using this formula. Here we have used cos theta minus I sin theta equal to e raised to minus I theta with theta equal to 2 pi by 5. So some authors are writing roots in exponential form also. Same thing here, this we can rewrite as e raised to I into theta, but here negative sign, so we have minus I into theta, which is 4 pi by 5, and this we can rewrite as e raised to minus 4 pi I divided by 5. And same thing here we have cos 4 pi by 5 plus I sin 4 pi by 5, so that I can write as, here we have positive sign, so we have e raised to I into theta, here angle theta is 4 pi by 5, so this I can rewrite as e raised to 4 pi I divided by 5. Same thing here angle is 2 pi by 5, so this we can rewrite as e raised to 2 pi I divided by 5, and this we can rewrite as e raised to 0 I. So some books or some authors are writing these roots in terms of exponential function also, so that is also correct. Either you can write in this trigonometric form or in exponential form. So in this way we can calculate fifth roots of complex number unity. So this is all about this session. I hope you like it. Thank you very much.